Hello everyone, welcome to my channel Coding Together. My name is Vikas Ojha. Today we will see another Leetcode problem, that is house robber. So it's a medium level question from the Leetcode and it's a very popular question, as you can see from the likes. So let's read the problem statement. Said you are a professional robber planning to rob houses along a street. So suppose these are the houses, one first, second, third, fourth, and each houses has money stashed in them. Like house 1 has 1 unit of money, house 2 has 2 unit of money, 3 unit of money, and 1 unit of money respectively. So now we have to rob these houses to get the maximum amount of money, but the only constraint is we cannot rob the adjacent houses, because there is a alerting that will go to the police if we rob the adjacent houses. So if we rob house number 1, we cannot rob house number 2. We have to go with the house number 3. So we have to find the maximum money. So for this example, if you see, if I rob house number 1 and then rob house number 3 with money 3, then I will have the total amount of 4, and that is the maximum money that I can rob. So let's try to solve this problem. Like we know the first way that comes into mind is brute force. Like suppose we have 1 2 3 1, we can apply brute force is recursively finding all the possibilities. Means, like for every house starting from the last house, I can rob that house, or I cannot rob her. I do not rob this house. Okay, once is if I rob this house, and second is I do not rob this house. So there are two possibilities for each house. So total is if 2 to power n possibilities, right? So the time complexity will be 2 to power n. So it will amount to 2 to power n. The complexity will amount to 2 to power n. So let's see the recursion relation. So let's see the recursion relation or recursion formula. What are the possibilities? That let's see an example to see all the possibilities. The first possibility can be if I'm robbing the last house. Suppose if I rob this index house, I can be able, and if the index is I will be only able to rob house that is I minus 2. I can rob I minus 2, right? So either first possibility is I rob house I and house I minus 2. So the first possibility is f of I plus f of I minus 2. Second possibility, if I do not rob I, I can rob I minus 1. So second possibility is if I rob I minus 1. Now what we have to take? We have to take the max of whichever the possibility is maximum. So this will be our recurrence relation, right? Now let's see with the same example and try to draw the recurrence tree for it, so to better understand the solution using brute force. So if I start with house number index 3, so if these are indexed from starting from 0, and these are the money, this is money and this is I. So if I start for house 3 and if I rob it, we can only rob the house index at 1, right? Now at index 1 again, if I am robbing index house at index 1, I can only I don't have any houses to rob, so it will be minus 1, right? Like suppose if, so it will be negative index, because for house at index 1 there is no house I minus 2, so it will be minus 1. If I don't rob house number 1 index at 1, I can rob house 0. So this will be rob and no rob. Now For -1, again at 3, if I don't rob it, if I no rob house at index 3, I can rob house at index 2. And when I rob house at index 2, I can rob house at index 0, right? According to this relation, according to this recurrence relation that we figured out, that is what it is stated in the question. Now if I don't rob house number 2, I can rob house number 1, right? If I rob house number 1, the house indexed as house number 1, I will go out of bound, I will go -1. And if I don't rob house at indexed 1, I can rob house 0. Now this will be our recursion tree. Now when we backtrack, if I go from house -1, what it will be? It will be 0, because there is no house, so the money in that house is 0. If I go back from house number 0, whatever the money indexed at that house, I can take that for the house 0, because suppose it's only one house index is 0, the only amount that I can rob is present in that house, so for 0 it will be 1. Now when I reached 1, now here's the important point, now I reached 1, I have to take the money for the house indexed at 1 plus the money I'm getting after robbing -1. So for -1 I'm getting 0. So now when we backtrack and when we reach 1, right, house indexed in 1, here's the important point. Now when we went for robbing, when we included 1 by robbing 1 itself, so left part is robbing itself, means we are including 1, so it will -1, it will be 0, and from 0 it will be -1, because for negative it will become 0. Now what will be the value at house indexed 1, that is 2. So it will be 0 plus 2 comma, what is the house indexed at 0, that is 1, value 1 comma 1, what is the maximum of this, that is 2, we'll return 2, right? Because for robbing we have to include whatever the left I minus 2 and plus the current index. So if we don't rob, if we no rob the current index, what we reach 2 and so on. So from here when we backtrack, from -1 we return 0, and for 0 what is the value of the money, that is 1. At 1 we will again take the maximum of current index money, that is 1 house indexed at 1, that will be 2 plus 0 comma, for the left part 2 plus 0 comma 1, what will be the maximum, 2. For 0 what is the value, that is 1. Now for robbing, what is the maximum? Now here again we have to take the maximum house index at 0, that is the money is 1, house index at 2, that is 3 plus 1 comma, what is the house index at 1, returning 2, so 2. So what is the maximum, that is 4, we'll return 4. And what is the maximum of 1 plus 3, 1 plus 3 comma 4, 1 plus 3 comma 4, that will be 4. So the maximum that we will get by robbing this house will be 4. It is evident, for 1 2 3 1, this one and this one, if we rob these two houses, what will be the maximum, 4. And while iterating this recurrence relation, also we found the same result. So this recurrence relation is holding true. Now important point, what is the time complexity? So time complexity will be 2 to power n. Time complexity will be 2 to power n, because we are branching out 2 times. either picking and non-picking, right? For every node we are parsing 2 times. And what are the maximum nodes we can have is the number of houses, right? Number of houses. So it will be 2 to power n, polynomial, sorry, exponential. Now can we reduce it? Can we reduce? Yes, we can reduce using dynamic programming. Memoization. So our recurrence relation will be remain same. Recurrence relation will remain the same, right? But what we can do, what can we do better is we can memoize some of the sub problems. We can memoize some of the sub problems. So if you see here, one is repeating, and again here one is repeating for the calls. So what we can do, we can cache this sub problem. We can cache this sub problem, and when in the next, in the future, if the same for the same house it arrives, we can save by taking it from the cache and saving the recurrence calls, recursive calls. So if you use memoization, what will be the time complexity? It will be order of n. It will reduce to order of n. Will linear time complexity, because it will iterate for only one house at a time. It will, the only maximum recursive calls will have, or maximum sub problems will have, is for each house. That's it. Now let's see the code part of it. So here we have n equal to num dot length, that is the number of houses. Now we have initialized our dp of size n. We have filled it -1. Now the base cases, we remember our base cases. If I is less than 0, if I is less than 0, what is returning? We are returning 0. And if I is equal to 0, then we're returning the nums I. If the value is present, if for that I, for that house, the value is present in the cache, we'll return from the cache. Otherwise we'll perform our recurrence relation, right? We'll take either the current I, we'll take the current I plus I minus 2 or I minus 1. The two recurrence relations we talked about. We draw our recurrence tree, and we'll take the maximum and we'll store in the DPI and we'll return the DPI phi. Let's try to run this problem. Very simple. So yeah, test cases are passing, so it means the program is running fine. So I hope you like this video. If you like this video, please share and subscribe. Thank you.